How does the Celsius scale measure temperature? Imagine trying to understand how hot or cold something is without a simple way to compare temperatures. That's where the Celsius scale comes into play, giving us a clear method to measure thermal energy. The Celsius scale measures temperature by setting to fixed points based on water's physical properties under normal atmospheric pressure. The first point is the freezing point of water, which is set at 0 degrees Celsius. The second is the boiling point of water, which is at 100 degrees Celsius. These 2 points are used to divide the temperature range into 100 equal parts, called degrees. This division makes the Celsius scale a centigrade scale, meaning 100 steps. Temperatures below 0 degrees Celsius are written as negative numbers, indicating colder conditions, while temperatures above 100 degrees Celsius are positive, showing hotter conditions. The scale was proposed by Anders Celsius in the year 1742. Interestingly, the original version had the numbers reversed, with 0 representing the boiling point of water and 100 the freezing point. But later, the scale was flipped to its current from for easier understanding and use. The Celsius scale is a relative scale, which means it depends on water's properties rather than an absolute 0 point. It is closely related to the Kelvin scale, which is an absolute temperature scale starting at absolute 0, the point where all molecular motion stops. Absolute 0 is minus 273.15 degrees Celsius or 0 Kelvin. In modern science, the size of 1 degree Celsius is exactly the same as 1 Kelvin. The triple point of water, where it can exist as solid, liquid, and gas simultaneously, is defined as exactly 0.01 degrees Celsius. This helps keep the scale precise and consistent. The Celsius scale is used in everyday life for weather reports, cooking, and scientific experiments because water's freezing and boiling points are easy to observe and reproduce. So, in simple terms, the Celsius scale measures temperature by assigning fixed points to water's freezing and boiling points, and then dividing that interval into 100 equal parts. This makes it a straightforward and practical way to understand and communicate thermal energy, based on familiar and observable phenomena.